This video explains how to use Farfield 2 to create a flexible pavement design on a stabilized base and modified subgrade. This video is part of the Farfield Pavement Design series by the Federal Aviation Administration Office of Airports. Refer to Advisory Circular AC 150/5320-6, Airport Pavement Design and Evaluation, and AC 150/5335-5, Standardized Method of Reporting Pavement Strength, PCR, for the basis of the design and evaluation procedures implemented in Farfield. In this video, we will develop a flexible pavement design on a stabilized base, add a user-defined layer representing a modified subgrade, and change the layer that Farfield uses as the design layer. Step 1. Name the job and section. Let's open an existing job of Farfield videos and add a new section, Flex Mod Sub. Step 2. Set the starting pavement structure. Click the pavement type drop-down menu and select New Flexible. This creates a starting structure with 4 layers: P401 HMA Surface, P401/403 HMA Stabilized, P209 Crushed Aggregate on a subgrade layer with a CBR of 10. Step 3. Edit the structure to reflect site conditions. In this example, adjust the subgrade CBR to 5. This would be as reported in the project's geotechnical report based on laboratory testing. See Chapter 2 of AC 150/5320-6 for additional information on soil investigations and evaluation. Step 4. Add traffic. In this example, use a stored aircraft traffic mix, the same as the traffic used in the example AC 150/5320-6G, Appendix H2. Note, you may have to create this traffic mix in Farfield, and save the traffic mix to File if you want to use this traffic mix again. 3,000 departures of a Boeing 737-800 with a gross taxi weight of 174,700 pounds, 2,500 departures of an Airbus A321-200 optional with a gross taxi weight of 207,014 pounds, 4,500 departures of an Embraer 195 STD with a gross taxi weight of 107,916 pounds, and 3,500 departures of a CRJ 700 aircraft with a gross taxi weight of 72,500 pounds. A stabilized base is required if the traffic mix includes aircraft that have a gross taxi weight of greater than 100,000 pounds. See AC 150/5320-6, Chapter 3, Paragraph 3.5 for discussion when to include a stabilized base and what properties it should have. Bases may be stabilized with asphalt or cement. Superior aggregate materials that exhibit a remolded soaked CBR of 100 or greater and have proven performance under similar climatic conditions may be substituted for stabilized base material. Step 5. Perform Farfield thickness analysis. Verify that the analysis mode is set to thickness design and then click the Run button. The analysis is complete once Farfield has adjusted the structure to achieve a CDF of 1. In our example, the recommended structure is 4 inches P401 HMA Surface, 5 inches P401 HMA Stabilized, 23.3 inches P209 Crushed Aggregate, on a subgrade with a CBR of 5. A review of the traffic reveals that the Airbus A321-200 is the most demanding aircraft, contributing 98% of the damage. Generally, in a flexible analysis, the heaviest aircraft with the highest tire pressure will be one of the most demanding aircraft on the pavement structure. Step 6. Adjust the structure, adding or deleting layers reflecting materials available and site conditions. The geotechnical report for the project recommended using a 12-inch layer of lime-treated subgrade. Laboratory tests have shown this will result in a long-term CBR of at least 25. To model this layer in Farfield, add a user-defined layer beneath the P209 layer by clicking the P209 layer in the image view. When the layer property box comes up, change layer type to user-defined with a thickness of 12 inches and a modulus of 37,500 psi. This represents a CBR of 25, as recommended in the Geotech report. Since Farfield uses modulus, E equals 1,500 times CBR, enter the modulus value using the same conversion formula. Finally, click Add Layer below. Verify that the user-defined layer is the layer above the subgrade and that the thickness and modulus are correct. Sometimes when adding or editing layers in the Farfield Layer Property window, Farfield does not save all information as expected. If this occurs, click the new layer in the Structure window and modify the properties, and then save by clicking OK. In a flexible analysis, Farfield selects the layer immediately above the subgrade as the design layer as indicated by the red arrow in the left column in the grid view. In a flexible analysis, Farfield allows the user to designate any of the layers beneath the surface and above the subgrade as the design layer. In our example, we want the design layer to be P209. To make this change in the grid view, click the P209 layer, then click the button Select as the design layer. Note that in the grid view, the red arrow is now on the P209 layer, indicating that this is the design layer. We run the thickness analysis by clicking the Run button. Once the analysis is complete, the Farfield design analysis indicates 4 inches P401 HMA surface, 5 inches P401 HMA stabilized, 10.5 inches P209 crush aggregate, and 12 inches user-defined on a subgrade with a CBR of 5. Last, adjust the layer thickness to construction thickness, a whole inch or 1/2 inch, and then run a life/compaction analysis. Once the analysis is complete, review the section report and save as a PDF for inclusion in the project's engineer's report. In this flexible design analysis, we demonstrated how to add a user-defined layer and how to change the analysis layer. These reference materials provide further guidance on designing, evaluating, and constructing airport pavements. Please visit www.faa.gov/airports to find these documents, this tool, and other related design tools. For additional information, contact the FAA's Office of Airports. The FAA appreciates your interest. Safe landing.